So there's one more thing I need to explain about lines, so you can do the first problem in the back of the chapter. And unfortunately, to explain that one, I can't use Pinta because it uses some funky algorithm for drawing lines. I don't know what it's doing. But so I'm going to revert to paint.net. So that's this guy. And unfortunately, sorry Mac people, this only runs on PCs. But at least you'll be able to get to see what's going on when I draw it here. So I'm going to start with drawing a line from 0, 0 to 7, 3. So you can see what's happening here with these. Here the pixels are represented by dots, and we're going to do. We're going to use this guy. And let me see if I can make a little note about what we're going to do. We're going to do draw a line from 0, 0 to 7, 3. Okay. So let's see. Here's 0, 0. And I'm going to 7, 4, 7, 3. Is that right? Let's see. Oh wait. Zero, 1, 2, 3. And 0, 1, 2, 3, 4, 5, 6, 7. Yeah, that's right. Okay. So we drew the line from 0, 0 to 7, 3. And now let's count the width of that line. So we're going to look at this whole rectangle that the line's contained in. So we're going to think about the width of the line and the height of the line, kind of. So the width of the line is, let's see, 0, 1, 2, 3, 4, 5, 6, 7. But the width is actually 8, right? 1, 2, 3, 4, 5, 6, 7, 8. So if we take 7, well, if we just said 7 plus 1, that would give us the right answer, right? But let's think about it a little bit more carefully. What if we hadn't started at 0, 0? What if we'd started someplace else? We would want to actually, let's do one over here that's the same width and height. So I'm going to start at 1, let's see, yeah, 0, 1, and 0, 1, 2, 3, 4. And I'm going to go, see if I can make one the same. So if that goes, let's see, 1, 2, 3, 4, 5, 6, 7, 8 this way, and 1, 2, 3, 4, is that right? 1, 2, 3, 4, yeah, that looks right. Okay, so this line is the same width and height, but it starts at 1, 4 and ends at 8, 7. So let's write that one up. So if we say G, draw a line from 1, 4 to 8, 7. Now if we think about what our width is, well, our width is, now we want to say maybe 8 minus 1, right? The difference between this starting x and that, the x that we ended up at and the x that we started at, and then add 1 to that, right? And that'll give us 8. So that should work whatever our starting x and ending x is. If we look at the difference of those and add 1, right? Almost. But remember, this line is equivalent to starting at, if we started at 8, 7 and ended at 1, 4, right? If we started here and drew the line this way, we'd draw the same line, but now we can't say 1 minus 8 plus 1. That won't give us the right answer, right? So what we need to do is look at this distance. So we need to take the absolute value, right? And then add 1 to that, and that'll give us the right width. And then the same thing with the height. We want to take the absolute value of, so our starting height is 7 and our ending height is 4. The absolute value of 4 minus 7 plus 1, right? So that'll be 3 plus 1 is 4, okay? So that's how we get our line width and our line height. Now, how do we figure out how many pixels there are in a line? And this is where Pinta fails, okay, because it doesn't draw lines the way that the drawLine function in Java would. It doesn't pick out the pixels the same way that this drawLine in Java does. So what happens, what you'll notice is that in each column there's exactly 1 pixel drawn. So in each column, right? So 1 here, 1 here, 1 here. So what happens here then is the number of pixels equals the width of the line. The number of pixels in the width, right? So we have 1, 2, 3, 4, 5, 6, 7, 8 pixels drawn, okay? There's a little bit of a snag here, because what if we draw a line like this? Okay, so now we have multiple pixels in a column, but look, there's exactly 1 pixel in each row. Okay? So what's happening there? Well, if and let's say that, write it like this, the absolute value of xb minus xa. So if the width of the line, let's just put it this way. If the width of the line is bigger than the height, right, then we can say, oh, okay, then the number of pixels is the width. Else, if the height is greater than the width, right? So now the height is 1, 2, 3, 4, 5, 6, 7, and the width is 1, 2, 3, 4. Then the number of pixels equals the height, right? And what if the width and the height are exactly the same? What happens? Let's take a look at that. So if the width and the height are exactly the same, like this, what that means is then it doesn't matter which one you use, right? Because the width gives you the number of pixels, so we have 1, 2, 3, 4, 5 is our width, and 1, 2, 3, 4, 5 is our height. But that's okay because there's exactly 1 pixel for each column and exactly 1 pixel for each row. So it's exactly 5. So we just need to check if the width is greater than height, make the number of pixels equal to the width. Otherwise, the number of pixels equals the height. And I wrote a little method to do that. Let me see. Yeah, right here. So basically our line width is going to be the absolute value of xb minus xa. Our line height is the absolute value of yb, or plus 1, right? Our line height is the absolute value of yb minus ya plus 1. And the number of pixels in a given line, if the line width is greater than the line height, then it's going to be the line width. Otherwise, it's the line height.